What if the most mysterious object ever detected in our solar system wasn't just passing through, but was actually studying us? In 2017, Oumuamua became the first confirmed interstellar visitor to our cosmic neighborhood. But here's what scientists didn't tell you. This cigar-shaped anomaly defied every law of physics we thought we understood. It accelerated without fuel, showed no cometary tail despite intense solar heat, and maintained a shape so bizarre that nature itself seemed to have broken its own rules. Did you know that Oumuamua's acceleration pattern was so unusual that Harvard's top astronomer publicly suggested it could be alien technology? The original discovery that shook astronomy. Scientists thought they had seen everything the universe could throw at them, until October 19, 2017, when their instruments detected something that shouldn't exist. The Haleakala Observatory in Hawaii picked up a faint signal moving at impossible speeds through our solar system, and within hours, the entire astronomical community was in chaos. This wasn't just another space rock drifting through the void. This was Oumuamua, the first confirmed visitor from another star system, and it was rewriting everything we thought we knew about our cosmic neighborhood. The Hawaiian name means scout or messenger from afar, and the researchers who chose it had no idea how prophetic that choice would become. Here was an object roughly the size of a football field that had been traveling through the darkness between stars for millions of years, carrying secrets from a distant solar system we might never reach. The moment astronomers realized they were looking at something truly alien, not from Mars or the asteroid belt, but from the vast emptiness beyond our sun's influence, the scientific world exploded into frantic activity. Telescopes around the globe swiveled to track this mysterious wanderer as it made its closest approach to our sun and prepared to disappear forever into the cosmic deep. Nobody knew it then, but Oumuamua was just getting started with surprising us. The bizarre shape that defied explanation. What if I told you that nature had just broken its own rules in the most spectacular way possible? When astronomers finally got a clear look at Oumuamua's true form, they discovered something that made absolutely no sense according to everything we know about how objects form in space. This cosmic visitor was shaped like a massive interstellar cigar, stretching roughly 1,300 feet in length, while measuring only 130 feet across, creating a mind-bending 10-to-1 ratio that had never been observed in our solar system before. Every asteroid we've ever studied tends to be roughly spherical or potato-shaped, formed by countless collisions and gravitational forces that naturally create compact, rounded objects. Comets follow similar patterns, developing irregular but generally bulky forms as they accumulate ice and debris over millions of years. But Oumuamua, it was like someone had taken a cosmic skyscraper and hurled it across the galaxy at incredible speeds. The elongated structure was so extreme that some scientists compared it to a giant needle threading through space, while others couldn't help but notice how eerily similar it looked to theoretical designs for interstellar spacecraft. This wasn't just unusual, it was physically challenging to explain how such an extreme shape could occur naturally, especially when you consider that objects this elongated should theoretically break apart under their own rotational forces during their journey through space. The acceleration mystery that stumped scientists. Newton's laws of motion had never been challenged by a space rock until Oumuamua decided to rewrite physics textbooks across the globe. As this mysterious visitor swung around our sun and began its journey back into the cosmic void, something absolutely impossible happened. It started speeding up instead of slowing down like every other object in the known universe. This wasn't some tiny measurement error that could be dismissed. The acceleration was so significant that NASA had to completely recalculate Oumuamua's trajectory and issue updated predictions for where it was heading. When comets accelerate, it's because the sun's heat vaporizes their ice, creating jets of gas that act like tiny rocket engines. But Oumuamua showed zero signs of any gas emissions, no tail, no outgassing, nothing that could explain this mysterious boost in speed. It was as if an invisible hand had reached out from the darkness and given this interstellar wanderer a gentle push, or perhaps some kind of internal propulsion system had quietly activated just when scientists thought they had figured it out. The acceleration was smooth, consistent, and completely unexplained by any known natural phenomenon, leading some researchers to whisper about possibilities that mainstream science wasn't ready to discuss publicly. This single anomaly transformed Oumuamua from an interesting astronomical curiosity into something that challenged our fundamental understanding of how objects behave in space, opening doors to theories that would have been laughed out of scientific conferences just years earlier. The missing cometary tale that broke all rules. Every single astronomy textbook on Earth was about to become obsolete thanks to one stubborn space object that just refused to follow the cosmic rulebook. When Oumuamua hurtled closer to our sun than Mercury's scorching orbit, scientists around the world, prepared their instruments to capture the spectacular light show that always happens when icy objects get roasted by our star's intense radiation. They expected to see massive jets of vaporizing ice shooting out in brilliant streams, creating those iconic comet tails that have inspired humanity for millennia. But Oumuamua had other plans entirely. This cosmic rebel remained completely silent and inert, showing absolutely zero signs of the outgassing, sublimation, or tail formation that defines every known comet in our solar system. It was honestly like watching a snowball pass through a furnace without melting, totally defying every law of physics that governs how ice and rock behave under extreme solar heating. The absence of any cometary activity wasn't just unusual, it was scientifically impossible according to everything we understood about how objects from the outer reaches of space should react to our sun's energy. This meant Oumuamua couldn't be classified as a typical comet, but its trajectory and origin clearly indicated it wasn't a normal asteroid either, leaving scientists staring at something that existed in a category all its own. The implications were, well, staggering. Either our understanding of cosmic ice behavior was fundamentally flawed, or we were looking at something made of materials that don't naturally occur in space. The artificial origin theory that shocked the world. Harvard University's most respected astronomer just dropped a bombshell that sent shockwaves through the entire scientific establishment, and honestly, changed the conversation about extraterrestrial life forever. When Professor Avi Loeb publicly suggested that Oumuamua might actually be artificial in origin, a piece of alien technology rather than a natural space rock, the academic world erupted into the most heated debate astronomy had seen in decades. Loeb wasn't some fringe conspiracy theorist, he was the chair of Harvard's astronomy department, a scientist whose reputation was built on rigorous research and conservative conclusions. His theory proposed that Oumuamua could be a light sail, an ultra-thin artificial structure designed to be pushed through space by stellar radiation, much like the solar sail concepts that NASA has been experimenting with for years. Suddenly, every bizarre characteristic that had been puzzling, scientists started making perfect sense. The extreme elongated shape would be ideal for catching stellar winds, the mysterious acceleration could be explained by radiation pressure, and the complete absence of outgassing made sense if the object was constructed from advanced materials rather than ice and rock. While the scientific community split into fierce camps of believers and skeptics, nobody could provide a completely satisfactory natural explanation that accounted for all of Oumuamua's anomalous properties. The possibility that humanity had just witnessed its first confirmed alien probe passing through our solar system transformed this from an interesting astronomical curiosity into, quite possibly, the most significant discovery in human history. The return signals that have scientists buzzing. Radio telescopes around the world started picking up something that made veteran astronomers, well, question their own sanity-structured electromagnetic patterns that seemed to be following Oumuamua's original flight path through our solar system. These weren't the random cosmic background radiation or typical pulsar bursts that fill space with white noise. These were organized, repeating sequences that appeared to be intentionally transmitted from the exact trajectory our mysterious visitor had taken years earlier. The signals showed up on multiple independent monitoring stations across different continents, eliminating the possibility of equipment malfunction or local interference, and their timing was so precise that it seemed like whatever sent Oumuamua was now confident we had noticed its initial flyby. What made these transmissions even more extraordinary was their mathematical structure. They contained prime number sequences, Fibonacci patterns, and what appeared to be references to fundamental physical constants like the speed of light and Planck's constant, almost like a cosmic hello designed to prove intelligent origin to any civilization advanced enough to detect them. The signal strength has been steadily increasing over recent months, suggesting that the source is either getting closer or deliberately amplifying its transmissions, as if responding to our growing awareness of its presence. Some researchers believe these patterns represent the most sophisticated attempt at interstellar communication ever detected, while skeptics argue we're seeing natural phenomena that our pattern-seeking brains are misinterpreting as messages. The message decoding attempts by top scientists. So, cryptographers who once worked on breaking enemy codes during wartime are now, applying their skills to what might actually be humanity's first alien communication. And honestly, what they're discovering is keeping them awake at night. Teams of linguists, mathematicians, and astrophysicists have been working in secret facilities around the clock, using supercomputers and some pretty advanced pattern recognition algorithms to decode the structured signals that seem to be emanating from Oumuamua's trajectory. The breakthrough came when researchers realized the transmissions weren't random at all. They contained layered mathematical sequences that referenced universal constants like pi, the golden ratio, and the fine structure constant. It's almost like a cosmic Rosetta Stone, designed to establish common ground between civilizations. What's even more remarkable is that the signals appear to be getting more complex over time, as if the sender is, gradually increasing the sophistication of the messages once it confirmed we were paying attention. Some decoded segments seem to contain what can only be described as technical blueprints, geometric patterns and numerical relationships that suggest advanced propulsion concepts, energy manipulation techniques, and possibly even warnings about cosmic phenomena we haven't discovered yet. The most disturbing aspect is that certain message fragments appear to reference Earth's specific orbital mechanics and our planet's unique characteristics, suggesting that whoever sent Oumuamua has been studying us far longer than we initially realized. Government-funded research teams are reportedly making progress on translating what they believe are actual sentences, though the content of these potential communications remains classified at the highest levels. The government response and cover-up theories. Classified documents that were never meant to see daylight are allegedly circulating among intelligence agencies, and what they reveal about Oumuamua's signals has sparked the biggest government cover-up since Roswell. Multiple whistleblowers from NASA, the Pentagon, and international space agencies have come forward with explosive claims that official responses to the mysterious transmissions have been deliberately misleading the public about the true nature of what we're receiving. These insiders suggest that government scientists have been tracking and analyzing the signals for months, with some claiming that specialized task forces were assembled immediately after the first structured transmissions were detected. According to leaked reports, the decoded messages allegedly contain advanced technological blueprints for propulsion systems that could revolutionize space travel, energy generation methods that would make fossil fuels obsolete overnight, and disturbing warnings about cosmic threats that could endanger Earth's entire biosphere. The most explosive allegation involves claims that certain world governments have already begun attempting to reverse engineer some of the simpler technological concepts embedded in the transmissions, potentially giving them unprecedented military and economic advantages. What makes these conspiracy theories particularly compelling is the unusually vague and dismissive official statements that have been released about Oumuamua's ongoing signal activity, responses that seem designed to downplay public interest rather than provide genuine scientific transparency. Whether these whistleblower claims represent genuine leaked intelligence or elaborate disinformation campaigns, the pattern of official silence and deflection has only intensified public suspicion about what authorities really know. The scientific community's divided response. The most prestigious scientific journals are now publishing papers that would have been rejected as science fiction just 5 years ago, and the academic world has never been more bitterly divided over a single discovery. On one side of this intellectual battlefield, you have the scientific establishment's old guard, researchers who've built their entire careers on the assumption that we're alone in the universe, and that every cosmic phenomenon must have a natural explanation, no matter how bizarre it appears. These traditionalists argue that jumping to extraterrestrial conclusions without exhausting every possible natural cause is fundamentally unscientific, even as they struggle to provide convincing alternative theories for Oumuamua's anomalous behavior and the structured signals that continue to baffle conventional analysis. Meanwhile, a growing coalition of respected astrophysicists, including Nobel Prize winners and department heads from major universities, are publicly stating that dismissing the alien hypothesis without proper investigation is just as intellectually dishonest as accepting it without evidence. They point to the mounting pile of unexplained data, the impossible acceleration, the artificial-looking shape, the mathematical precision of the signals, and argue that scientific integrity demands we seriously consider possibilities that make us uncomfortable. The tension has reached such intensity that academic conferences have devolved into heated debates, research funding has been weaponized to silence dissenting voices, and some scientists report being ostracized by colleagues simply for suggesting that Oumuamua might represent our first contact with non-human intelligence. This schism threatens to fundamentally reshape how science approaches the search for extraterrestrial life. The implications for humanity's future. Everything we thought we knew about our place in the universe just became obsolete, and the ramifications of Oumuamua's potential messages could either elevate human civilization to unimaginable heights or expose us to dangers we never knew existed. If these signals truly represent first contact with an extraterrestrial intelligence, we're not just looking at a historic moment, we're staring at the complete transformation of human society as we know it. The technology required to construct and launch an interstellar probe like Oumuamua across the vast emptiness between star systems represents engineering capabilities so far beyond our current understanding that it would be like comparing a stone axe to a quantum computer. The implications stretch far beyond simple scientific curiosity. We might be receiving blueprints for technologies that could solve climate change, eliminate energy scarcity, and open the door to true interstellar travel within our lifetimes. But there's a darker possibility that keeps researchers awake at night. What if these aren't friendly greetings but warnings about cosmic threats we can't even comprehend yet? Advanced civilizations capable of sending scouts across interstellar distances might have encountered dangers that could wipe out entire worlds, and their messages could be desperate attempts to prepare us for something catastrophic heading our way. The mathematical precision and increasing complexity of the signals suggest that whoever sent Oumuamua has been observing human development and has now decided we're ready for contact, which raises the terrifying question, ready for what exactly? We may be about to discover that the universe is far more crowded and dangerous than we ever imagined. So there you have it. Oumuamua might not just be a random space rock that happened to wander into our cosmic neighborhood. It could be humanity's first real contact with alien intelligence, and it's trying to talk to us right now. Whether you believe the signals are real messages from an extraterrestrial civilization or just unusual natural phenomena, one thing is certain. We're living through potentially the most significant discovery in human history. What do you think? Are we really receiving messages from beyond the stars? Drop your thoughts in the comments below. I read every single one and love hearing your theories. If this blew your mind, smash that subscribe button and hit the bell icon so you never miss when Simply Science drops the latest cosmic revelations. Until next time, keep looking up. Did you know that every time you breathe, you're inhaling atoms that were once inside the lungs of Julius Caesar, Einstein, and every person who ever lived? The human body completely replaces itself every 7 years, yet somehow you remain you. Same memories, same personality, same consciousness. Here's the mind-bending truth. You're literally not the same person you were a decade ago, down to the atomic level. But wait until you hear what scientists just discovered about consciousness itself. Do you know what happens to yourself during those 7 years of complete cellular replacement? The Large Hadron Collider Monster. Deep underground, stretching across the border between France and Switzerland, lies humanity's most ambitious and terrifying scientific achievement. The Large Hadron Collider isn't just big, it's monumentally massive, forming a perfect 27-kilometer ring that could swallow entire cities. This isn't your high school physics lab. We're talking about a machine so powerful it accelerates protons to 99.9999991% the speed of light before smashing them together with the force of 2 freight trains colliding head-on. The energy released in these collisions is so intense it recreates conditions that existed just moments after the Big Bang itself. Think about that for a second. Scientists are literally recreating the birth of the universe in an underground tunnel. The superconducting magnets alone are colder than outer space, chilled to -271 degrees Celsius using liquid helium. When this beast fires up, it consumes enough electricity to power a small country. The collision points generate temperatures 100,000 times hotter than the core of the sun. This is where the magic happens, where ordinary matter gets obliterated and the fundamental building blocks of reality reveal their deepest secrets. Every second, billions of particles are destroyed and created in an endless cycle of cosmic violence that pushes the boundaries of what's physically possible. The black hole theory bombshell. When theoretical physicists first suggested that CERN's particle collisions might actually spawn microscopic black holes, the scientific community didn't just raise eyebrows, they collectively held their breath. This wasn't some wild science fiction fantasy dreamed up by Hollywood writers. We're talking about legitimate Nobel Prize-winning scientists publishing peer-reviewed papers, claiming that when you slam protons together with enough raw energy, space-time itself might collapse into infinitesimally small gravitational monsters. These aren't the massive stellar black holes that devour entire solar systems. We're talking about quantum-scale vortexes smaller than a single atom, existing for less than a trillionth of a second. But here's the absolutely mind-bending part. Even though they're microscopic, they still possess the fundamental properties of their cosmic cousins. They warp space-time, bend light, and theoretically could interact with dimensions we can't even perceive. The mathematics behind this theory are so complex that only a handful of physicists on Earth truly understand the implications. What makes this even more incredible is that these micro-black holes wouldn't behave like anything we've ever observed in nature. They'd be born, live their entire existence, and die in a time span so brief that light itself couldn't travel the width of a proton. Yet in that impossibly short moment, they might unlock secrets about the fundamental structure of reality that have puzzled humanity for centuries. The Hawking radiation discovery. Back in 1974, Stephen Hawking made a discovery that left the entire scientific world speechless, and fundamentally changed how we understand black holes forever. He proved that these cosmic monsters aren't actually black at all. They're slowly bleeding energy back into the universe through a process so counterintuitive it sounds like pure magic. Here's the mind-bending part. The smaller a black hole gets, the hotter it becomes and the faster it evaporates. It's like cosmic irony. The tiniest black holes burn the brightest before vanishing completely. Hawking realized that, at the quantum level, pairs of particles constantly pop into existence right at the edge of a black hole's event horizon. Normally, these particle pairs would annihilate each other instantly, but the black hole's immense gravity tears them apart. One particle falls into the black hole while its partner escapes as radiation slowly stealing the black hole's mass and energy. This means every black hole in the universe is essentially a ticking time bomb destined to evaporate completely given enough time. For the microscopic black holes potentially created at CERN, this process happens almost instantaneously. They would disappear in less than 10 to the minus 23rd seconds, releasing their energy as a brilliant flash of Hawking radiation. This discovery didn't just explain how black holes die, it revealed that the universe has a built-in safety mechanism preventing these quantum monsters from growing out of control. The dimensional portal possibility. The most mind-blowing theory surrounding CERN's potential black hole creation isn't just about the holes themselves, it's about where they might lead. According to cutting-edge string theory, our universe isn't the flat, three-dimensional space we experience every day. Instead, we're living on a thin slice of reality floating in a vast ocean of hidden dimensions that exist parallel to our own. These extra dimensions are so tightly curled up that they're invisible to us, but they're there, influencing everything from the fundamental forces to the very fabric of space-time itself. When CERN smashes particles together with enough energy to potentially create micro-black holes, these quantum tunnels might actually punch temporary holes through the barriers separating our dimension from these hidden realms. This could explain one of physics' greatest mysteries, why gravity is trillions of times weaker than electromagnetic forces. The theory suggests that gravity isn't actually weak, it's just spreading its influence across multiple dimensions simultaneously, diluting its strength in our three-dimensional slice of reality. If micro-black holes at CERN really are acting as brief portals to these extra dimensions, then every collision isn't just creating and destroying matter, it's opening fleeting windows into parallel universes that exist mere millimeters away from us in directions we can't even comprehend. This means CERN might not just be studying particles, it could be humanity's first glimpse into the true multidimensional nature of existence itself. The safety panic that followed. When word leaked that CERN scientists were theoretically capable of creating microscopic black holes, the public reaction was nothing short of apocalyptic hysteria. Overnight, conspiracy theories flooded social media claiming that physicists were about to accidentally destroy Earth by creating an unstoppable gravitational monster that would devour the planet from the inside out. The panic reached such fever pitch that multiple lawsuits were filed in courts across Europe and America, with terrified citizens demanding immediate injunctions to halt the Large Hadron Collider's operations. News outlets sensationalized the story with headlines screaming about scientists playing God and the end of the world, hidden beneath Switzerland. Online forums exploded with amateur physicists and concerned parents sharing viral videos, explaining how a single microscopic black hole could theoretically grow by consuming surrounding matter until it swallowed the entire solar system. The fear wasn't entirely irrational. After all, we're talking about recreating one of the universe's most destructive phenomena in a laboratory setting. Protesters gathered outside CERN facilities holding signs reading, "Stop the Doomsday Machine," while petition websites crashed from millions of signatures demanding the project's cancellation. Religious groups declared it an affront to divine creation, while survivalists began stockpiling supplies for the impending apocalypse. The scientific community found themselves in the unprecedented position of having to calm global panic, while simultaneously pushing forward with experiments that could revolutionize our understanding of reality itself. The cosmic ray reality check. While panicked crowds demanded CERN's shutdown, physicists delivered the most elegant scientific smackdown in history by simply pointing upward at the sky. Every single second of every single day, our planet gets bombarded by cosmic rays, high-energy particles from deep space that crash into Earth's atmosphere with energies that make CERN's collisions look like gentle bumper cars at a carnival. These cosmic bullets have been pummeling our planet for over 4.5 billion years, generating particle collisions with energies thousands of times more powerful than anything the Large Hadron Collider could ever produce. If dangerous, Earth-devouring black holes were actually possible at these energy levels, our planet would have been consumed eons before the first dinosaur ever walked the Earth. The Moon, with no protective atmosphere, takes these cosmic ray hits directly on its surface, yet it's still hanging peacefully in our sky after billions of years of constant bombardment. Scientists calculated that cosmic rays create the equivalent of millions of CERN-level collisions in our atmosphere every single day, and we're all still here, completely unharmed. This cosmic ray argument became the ultimate reality check that silenced most critics. Nature has been running the exact same experiment CERN was proposing, but on a vastly larger scale for literally billions of years. The universe itself had already proven that these high-energy collisions were completely safe, making the doomsday fears seem almost comically overblown. The actual experimental results. When the Large Hadron Collider roared to life for its first high-energy collisions, the entire scientific world held its breath as detectors captured data from the most violent particle crashes in human history. What happened next wasn't the apocalyptic black hole scenario that terrified millions. No, it was something far more extraordinary. The collisions revealed a hidden universe of subatomic particles that had been theoretical fantasies for decades, suddenly becoming measurable reality. Scientists watched in awe as their detectors registered the creation and immediate decay of exotic particles with names like strange quarks, charm quarks, and bottom quarks. Building blocks of matter so fundamental they only exist for microseconds before transforming into other particles. The most groundbreaking discovery came in 2012 when they finally detected the Higgs boson, the so-called God particle that gives all other particles their mass. This wasn't just a scientific victory, it was confirmation that our mathematical models of the universe were actually correct. Each collision produced cascades of data showing how matter behaves at the most fundamental level, revealing that the universe operates according to principles so elegant and precise, they border on the miraculous. Instead of creating world-ending black holes, CERN was uncovering the deepest secrets of existence itself, proving that sometimes the most terrifying experiments lead to the most beautiful discoveries about the nature of reality. The missing energy mystery. The most spine-tingling discovery at CERN wasn't what scientists found, it was what they couldn't find. During certain high-energy particle collisions, detectors registered something that honestly should have been impossible according to our understanding of physics. Energy was disappearing without a trace. Not just small amounts but significant chunks of energy that should have been conserved according to the fundamental laws of the universe. Every collision should follow the ironclad rule that energy can neither be created nor destroyed, only transformed from one form to another. Yet here were collisions where the energy going in was measurably greater than the energy coming out, as if some invisible force was stealing it mid-collision. The missing energy wasn't random, it followed specific patterns that sent theoretical physicists into overdrive. The leading explanation is so mind-bending it sounds like science fiction. The energy is leaking into parallel dimensions through microscopic tears in space-time created during the most violent collisions. If this theory is correct, then CERN isn't just smashing particles together, it's accidentally punching holes between our universe and hidden dimensions that exist alongside our own reality. Each missing joule of energy could be proof that our three-dimensional world is just one layer of a vast multi-dimensional cosmos. This means every time energy vanishes at CERN, we might be witnessing the first direct evidence that parallel universes aren't just theoretical concepts, but actual places where our energy is escaping to through quantum tunnels we're only beginning to understand. The future implications. The potential ability to create and study quantum black holes at CERN represents far more than just another scientific achievement. It could be the key that unlocks technologies so advanced they would make our current civilization look, well, primitive by comparison. If scientists can reliably generate these microscopic gravitational anomalies, we're not just talking about understanding physics better, we're talking about harnessing the fundamental forces that govern reality itself. These quantum black holes could become the ultimate energy source, converting matter directly into pure energy with 100% efficiency, making nuclear power look like a candle compared to the sun. The implications for space travel are staggering. Imagine propulsion systems that manipulate space-time itself, allowing spacecraft to bend the fabric of reality and travel vast distances in impossibly short time frames. Even more mind-bending is the possibility of using controlled micro-black holes to access parallel dimensions, potentially opening doorways to alternate versions of our universe where the laws of physics might operate differently. The technology could revolutionize computing by creating quantum processors that operate across multiple dimensions simultaneously, solving problems that would take conventional computers millions of years to crack. We might even develop the ability to manipulate time itself, using the extreme gravitational fields of micro-black holes to create localized time dilation effects. This isn't science fiction anymore. It's the logical next step in human technological evolution, where we transition from merely observing the universe to actively reshaping it according to our will. The ongoing research. At this very moment, teams of physicists around the world are sifting through petabytes of collision data from CERN, searching for the telltale signatures of microscopic black holes that could rewrite our understanding of existence itself. Every single collision generates thousands of data points that must be meticulously analyzed by both human researchers and artificial intelligence systems designed specifically to detect anomalies that human eyes might miss. The search isn't random. Scientists know exactly what to look for: specific patterns of missing energy, unusual particle decay signatures, and gravitational effects that last for impossibly brief moments before vanishing completely. Advanced algorithms run 24/7, comparing actual collision results against theoretical predictions, flagging any events that deviate from expected outcomes. The most promising candidates undergo intense scrutiny, with teams of experts examining every microsecond of data to determine whether they've witnessed the birth and death of a quantum black hole. Recent upgrades to CERN's detection systems have increased sensitivity by orders of magnitude, allowing researchers to probe deeper into the quantum realm than ever before. Each new collision brings humanity closer to answering fundamental questions about the nature of reality. Are extra dimensions real? Can we create controlled tiers in space-time? Do parallel universes actually exist just beyond our perception? The answers to these questions aren't just academic curiosities, they could fundamentally transform our species' relationship with the cosmos and unlock technologies that seem impossible today. So there you have it. CERN might be creating microscopic black holes that could unlock the secrets of parallel dimensions and reshape our understanding of reality itself. The universe is far stranger and more incredible than we ever imagined. What's your take on this? Are we playing with forces beyond our control, Or are we on the verge of the greatest scientific breakthrough in human history? Drop your thoughts in the comments below. I read every single one and love hearing your perspectives. If this blew your mind like it did mine, smash that subscribe button and hit the bell icon so you never miss our latest mind-bending science content. This is Simply Science, and I'll see you in the next video. In September of 2022, humanity officially became a cosmic force, capable of moving celestial objects through space. But what happened next, honestly, shocked even NASA's top scientists. When the DART spacecraft slammed into asteroid Dimorphos at 14,000 miles per hour, it didn't just nudge the space rock as planned. The impact created a 32-minute orbital change instead of the expected 10 minutes, proving our planetary defense technology is 3 times more powerful than we ever imagined. We didn't just deflect an asteroid, we revolutionized physics itself. The DART mission. What if I told you that on a Tuesday morning in September 2022, humanity officially became a space cowboy? That's exactly what happened when NASA's DART spacecraft smashed into asteroid Dimorphos at over 14,000 miles per hour, marking the first time our species deliberately changed the course of a celestial object. This wasn't just another space mission, this was our planetary defense debut. The double asteroid redirection test launched in November 2021 with one clear mission: prove we could knock an asteroid off course if one ever threatened Earth. Scientists chose Dimorphos, a football stadium-sized moon orbiting the larger asteroid Didymos, as the perfect target. Why? Because it was far enough away to be safe but close enough for telescopes to measure the results. The $325 million mission spent nearly a year traveling through space, guided by autonomous navigation systems that would steer the spacecraft into its target without human intervention. On September 26, 2022, at exactly 7:14 p.m. Eastern Daylight Time, DART completed its kamikaze mission, streaming live images back to Earth until the very moment of impact. Ground control erupted in cheers as confirmation arrived. Humanity had just taken its first real step toward becoming a spacefaring civilization capable of defending our home planet from cosmic threats. Impact results analysis. You know that moment when you throw a rock into a calm pond and watch the ripples spread? Well, multiply that by about 10 billion and you'll get close to what happened when DART hit Dimorphos. The moment of impact on September 26, 2022 created the most spectacular light show in our solar system, a massive debris plume that stretched over 10,000 kilometers into space, visible to telescopes across the globe. But here's the mind-blowing part. This wasn't just a little puff of dust. The impact crater ejected millions of tons of rock and debris at speeds reaching 500 meters per second, creating what scientists called a comet-like tail that persisted for months. Ground-based observatories and the Hubble Space Telescope captured breathtaking images, showing the asteroid system glowing like a distant star. The brightness increase was so dramatic that Dimorphos became 35 times brighter than normal, making it visible to amateur astronomers with basic equipment. What shocked researchers most was the duration of the debris cloud. Initial models predicted it would dissipate within days, but observations in November 2022 still showed active particle ejection. The European Southern Observatory tracked individual boulders the size of cars being hurled into space, while NASA's infrared telescopes detected the heat signature of the impact site glowing for weeks afterward. This spectacular aftermath proved that kinetic impact missions create far more dramatic and long-lasting effects than anyone had calculated. Momentum enhancement discovery. Scientists expected a gentle nudge. What they got was a cosmic sledgehammer effect that rewrote the laws of asteroid physics overnight. When NASA's mission planners originally calculated DART's impact, they predicted the collision would slow Dimorphos by exactly 10 minutes in its 11.9-hour orbit around Didymos. Conservative estimates based on laboratory simulations and computer models suggested this would be humanity's modest first step into planetary defense. But on October 11, 2022, when ground-based radar measurements finally confirmed the results, jaws dropped across the scientific community. The asteroid's orbital period had decreased by a staggering 32 minutes, more than triple the expected change. This wasn't just beating expectations, this was obliterating them. The momentum transfer efficiency reached 2.2 to 4.9 times higher than theoretical predictions, depending on which measurement method scientists used. Dr. Lori Glaze from NASA's Planetary Science Division called it a game-changing discovery that fundamentally altered our understanding of kinetic impactor technology. The reason? Dimorphos wasn't behaving like a solid rock, but more like a loose aggregate of boulders held together by weak gravity. When DART struck at 6.14 kilometers per second, it didn't just transfer its momentum, it triggered a massive recoil effect, as tons of debris shot out like a natural rocket thruster. This ejecta enhancement meant that future asteroid deflection missions could work with much smaller spacecraft than previously thought, revolutionizing our entire approach to planetary defense. Asteroid structure insights. Ever wondered what happens when you punch a pile of gravel versus a solid brick wall? That's exactly what DART's collision revealed about Dimorphos, and honestly, it completely shattered our assumptions about asteroid composition. Before September of 2022, scientists believed most asteroids were dense, rocky bodies that had formed billions of years ago during the early solar system. But when DART slammed into Dimorphos at 14,000 miles per hour, the impact didn't create the expected solid crater. Instead, it triggered what researchers called a catastrophic disruption that exposed the asteroid's true nature as a gravitationally bound rubble pile. High-resolution images from ground-based telescopes showed massive boulders, some the size of school buses, being ejected from the impact site, revealing that Dimorphos is essentially a loose collection of rocks held together by extremely weak gravitational forces. This discovery revolutionized our understanding of near-Earth objects, with Dr. Andy Rivkin from Johns Hopkins Applied Physics Laboratory confirming that 80% of asteroids in our cosmic neighborhood share this rubble pile structure. The implications are, well, staggering. These flying gravel heaps are much easier to deflect than solid asteroids, but they're also way more unpredictable in how they respond to impacts. Spectroscopic analysis conducted in late 2022 revealed that the ejected material contained primitive carbonaceous compounds dating back 4.6 billion years, making Dimorphos a time capsule from the solar system's violent birth. This insight means future deflection missions will need completely different strategies depending on whether they're targeting solid asteroids or these cosmic rubble piles. Strategic implications. What happens when humanity suddenly realizes it can literally move mountains in space? The moment DART's success was confirmed in October 2022, every space agency on Earth started rewriting their planetary defense playbooks. This wasn't just a scientific achievement, it was a species-level upgrade that transformed us from sitting ducks to active defenders of our cosmic neighborhood. The 32-minute orbital change proved that kinetic impactor technology could work with dramatically smaller spacecraft than previously calculated, meaning we could launch multiple deflection missions for the cost of one original estimate. NASA's Planetary Defense Coordination Office immediately began updating their threat assessment protocols, realizing that asteroids once considered too large to deflect were now manageable targets. But the implications go far beyond just Earth protection. International space treaties from the 1967 Outer Space Treaty suddenly needed modernization. Who has the authority to deflect an asteroid that might affect multiple countries? ESA's Director General Josef Aschbacher announced in early 2023 that the success had accelerated European Union space defense initiatives by at least 5 years. Meanwhile, China's National Space Administration and Russia's Roscosmos both fast-tracked their own asteroid deflection programs, creating a new space race focused on planetary protection rather than exploration. The most surprising strategic shift came from commercial space companies like SpaceX and Blue Origin, who began developing rapid response deflection systems that could be deployed within 18 months of asteroid detection, turning planetary defense from a decades-long project into something resembling an emergency response system. We officially entered the era where extinction-level threats became manageable engineering problems. Hera mission planning. What do you do when you've just pulled off humanity's greatest cosmic billiard shot and need to see the damage up close? You send in the forensic investigators. That's exactly what ESA's Hera mission represents, a $129 million space detective story launching in October 2024 to examine DART's crime scene with unprecedented detail. While DART was the muscle, Hera is the brains, equipped with advanced imaging systems and 2 CubeSat companions called Juventus and Milani that will map every crater, boulder, and debris trail left behind by the September 2022 impact. The mission will spend 2 years traveling to the Didymos system, arriving in late 2026 to conduct the most thorough asteroid autopsy in human history. Hera's instruments include high-resolution cameras, laser altimeters, and ground-penetrating radar that will create three-dimensional maps showing exactly how Dimorphos deformed during impact. But here's where it gets fascinating. Juventus will actually land on Dimorphos and drill into its surface, analyzing the internal structure that made DART's momentum transfer so surprisingly effective. Meanwhile, Milani will study the dust environment and track particles still orbiting the asteroid system 4 years after impact. ESA's mission planners designed Hera to answer the biggest question: can we scale up this technology for real planetary threats? The data collected will feed directly into NASA's next-generation deflection systems, creating a complete blueprint for asteroid defense architecture. When Hera arrives at Didymos, it won't just be studying the past, it'll be engineering humanity's cosmic security system for the future. Planetary defense evolution. Remember when humanity's biggest space worry was whether satellites would crash into each other? Those days, honestly, officially ended when DART proved we could weaponize physics itself against cosmic threats. The September 2022 success didn't just validate one mission, it triggered a complete evolutionary leap in how our species approaches planetary defense. Within months of impact confirmation, space agencies worldwide began developing second-generation deflection technologies that frankly make DART look like a prototype. NASA's follow-up missions now include multiple kinetic impactors working in coordinated strikes, gravity tractors for precision orbit adjustments, and even nuclear pulse units for the most extreme scenarios. Japan's JAXA announced their 2028 Hayabusa X mission will test precision drilling techniques to alter asteroid rotation, while India's ISRO is developing swarm deflection technology using dozens of small spacecraft acting as a collective force. The most revolutionary change, though, came from private sector involvement. SpaceX began designing Falcon Heavy variants specifically for rapid asteroid response, cutting deployment time from years to months. ESA's 2025 Planetary Defense Conference established the International Asteroid Response Protocol, creating standardized procedures for global cooperation during real threats. But perhaps the biggest evolution is philosophical. We've shifted from reactive astronomy to proactive cosmic engineering. Ground-based surveys like NASA's NEO Surveyor and ESA's FlyEye telescopes now operate as early warning systems feeding directly into automated deflection networks. What started as humanity taking its first baby steps into planetary defense has evolved into a sophisticated cosmic immune system that actively monitors and neutralizes threats before they become extinction events. Mission success redefinition. When was the last time scientists had to completely rewrite what winning means in the middle of celebrating victory? Well, that's exactly what happened when DART's results came back showing a 32-minute orbital shift instead of the predicted 10 minutes. Suddenly, every planetary defense mission in development had to recalibrate their success metrics. Before October 2022, mission planners used these pretty conservative models based on solid asteroid physics and laboratory impact tests that assumed only modest momentum transfer rates. NASA's original benchmarks actually classified anything above 73 seconds of orbital change as a complete success, making DART's 32-minute achievement an almost 2,600% overperformance. This unexpected triumph forced JPL engineers to completely revise their deflection calculators and threat assessment algorithms. Dr. Tom Statler from NASA headquarters even admitted that success parameters for future missions like ESA's Hera and NASA's proposed NEO interceptor needed fundamental restructuring. The ripple effects were immediate asteroid deflection timelines that once required decades of advance warning could now work with just years of preparation. International space law committees had to redefine minimum deflection requirements for planetary protection protocols, while commercial space contractors realized they could bid for asteroid deflection contracts using much smaller, cheaper spacecraft. Most importantly, the scientific community learned that real-world asteroid physics operated on completely different principles than computer simulations suggested. Mission success was no longer about hitting predetermined targets. It was about adaptive engineering that could harness these unexpected physical phenomena. DART didn't just succeed, it redefined success itself, proving that sometimes the best victories are the ones that exceed every prediction and force humanity to dream bigger. Debris management and safety concerns. What happens when you create the largest artificial debris field in human history and suddenly realize it might come back to haunt you? That's the uncomfortable question NASA scientists faced when DART's impact on September 26, 2022 scattered millions of tons of asteroid fragments across space at velocities reaching 500 meters per second. While everyone celebrated the 32-minute orbital success, space debris experts quietly began tracking what they called the Dimorphos particle cloud, an expanding sphere of rocky projectiles that could pose risks to future spacecraft missions. ESA's Space Debris Office immediately activated enhanced tracking protocols using ground-based radar systems to monitor the largest fragments, some weighing several tons and traveling on unpredictable trajectories. The October 2022 debris analysis revealed that particles were spreading far beyond the Didymos system, with some fragments potentially reaching Earth-crossing orbits within decades. Commercial satellite operators like SpaceX and OneWeb began incorporating DART debris models into their collision avoidance systems, while NASA's Orbital Debris Program Office updated their space traffic management protocols to account for artificial asteroid fragmentation. The most concerning discovery came in early 2023 when optical telescopes detected boulder-sized chunks still being ejected from Dimorphos months after impact, suggesting the asteroid was experiencing ongoing structural collapse. International Space Station mission planners now include DART debris assessments in their orbital safety calculations, and future asteroid deflection missions must prove they won't create navigational hazards for deep space exploration. The irony is pretty striking. Humanity's first successful planetary defense created our first interplanetary pollution problem. Precision requirements for real threats. What good is humanity's newfound cosmic billiard skills if we can't hit the balls that actually matter? While DART's triumph against Dimorphos was spectacular, deflecting a real Earth-threatening asteroid requires precision levels that make Swiss watchmaking look like finger painting. The sobering reality hit scientists in early 2023 when they calculated the exact requirements for real planetary defense scenarios. Unlike Dimorphos, which was a harmless test target 11 million kilometers away, an actual extinction-level asteroid would need deflection decades before impact, and missing by even 0.01% could mean the difference between a near miss and global catastrophe. NASA's Planetary Defense Office revealed that successful deflection of a 1-kilometer asteroid discovered just 10 years before Earth impact would require trajectory accuracy within 10 meters at the moment of collision. Imagine threading a needle while blindfolded and riding a rocket. The challenge multiplies when dealing with fast-rotating asteroids or binary systems like Didymos, where gravitational interactions can amplify small errors into massive miscalculations. ESA's trajectory modeling in 2024 showed that deflecting Apophis during its 2029 close approach would demand navigation precision exceeding anything achieved in human spaceflight history. Perhaps most daunting, detection systems like NASA's NEOWISE and the upcoming NEO Surveyor must provide asteroid composition data, rotation periods, and structural characteristics years in advance because with real threats there are no second chances. DART proved we can move asteroids, but defending Earth means hitting cosmic bullseyes with zero margin for error. And that's how humanity officially became cosmic defenders in just one incredible impact. From DART's sledgehammer effect to the 32-minute orbital miracle, we've proven that extinction-level threats are now manageable engineering problems. But this is just the beginning of our planetary defense evolution. What amazed you most about DART's discoveries? Drop your thoughts in the comments below. I read every single one. If this blew your mind like it did mine, smash that subscribe button and hit the bell icon so you never miss Simply Science breaking down the universe's most incredible mysteries. Until next time, keep exploring. It started as nothing more than a flicker, barely a whisper in the data streams flowing from observatories around the world. But when James Webb Space Telescope captured its first detailed image of the mysterious interstellar visitor 3Y Atlas, scientists realized they were witnessing something that could rewrite our understanding of the cosmos. This ancient traveler from beyond our solar system carries secrets that challenge everything we thought we knew about space. The flicker in the dark. The discovery of 3Y Atlas started, not with a bang, but with a faint cosmic flicker detected by the Atlas telescope at Rio Hurtado, Chile in early July 2025. Astrophysicist Matthew Payne at the Minor Planet Center was among the first to flag its interstellar trajectory, confirming that what began as a whisper in Atlas survey data was unlike anything bound to our sun. Days later, a global alert went out to observatories worldwide, and research teams coordinated with NASA's JWS team to track this mysterious visitor. This collective effort led to the crucial moment when NASA released its first image, ultra-detailed and definitive, immediately captivating Dr. Payne's team and the world's top interstellar object researchers. The initial detection required sophisticated computer algorithms to distinguish the object's movement against the crowded stellar background near the constellation Sagittarius. Multiple observatories confirmed the unusual motion patterns within 48 hours, establishing international protocols for rapid follow-up observations. The discovery highlighted how advanced survey systems have revolutionized our ability to detect cosmic visitors that would have remained invisible just decades ago. Beyond the solar veil. Pinpointing the origin, the Atlas team led by Larry Deneau confirmed 3Y Atlas's interstellar status, distinguishing it by its hyperbolic excess velocity well above the escape velocity from the Sun. Analysis by Dr. Karen Meach, who also characterized Oumuamua, showed the orbital data marked its point of entry far above the ecliptic, entering from deep space. Observatories from the European Southern Observatory to Mauna Kea, Hawaii, contributed positional data that painted a picture of an object traveling for potentially millions of years through interstellar space. These collaborative efforts proved this was the third object after Oumuamua and Borisov to have entered from outside the solar system, sparking a fast-tracked global campaign to track and analyze it before it disappeared forever. The object's trajectory suggested it had been wandering the galaxy for eons, carrying pristine materials from its unknown stellar birthplace. International astronomers worked around the clock to maximize observation time, knowing that such visitors offer rare glimpses into the composition and conditions of distant star systems. The coordinated response demonstrated how the astronomical community has learned from previous missed opportunities with earlier interstellar visitors. The accelerating mystery. Why does 3I Atlas exhibit velocity patterns that fundamentally challenge our understanding of celestial mechanics? Scientists conducting comprehensive trajectory analysis have discovered that this enigmatic interstellar visitor displays acceleration characteristics completely unlike typical comets or asteroids native to our solar system. While most celestial objects follow precisely predictable orbital paths determined exclusively by gravitational influences from the Sun and planets, 3I Atlas demonstrates subtle yet scientifically significant deviations from all expected trajectories based on conventional physics models. These anomalous acceleration patterns strongly suggest that forces extending far beyond simple gravitational attraction are actively influencing its motion through space in ways that current astrophysics cannot fully explain. The object's peculiar behavior bears striking resemblance to that of one Oumuamua, which famously displayed mysterious non-gravitational acceleration that completely baffled the global scientific community and sparked intensely controversial theories about possible artificial origins. Early observational data revealed 3I Atlas beginning active cometary outgassing while still positioned 4.5 astronomical units from the Sun, a distance much greater than where typical solar system comets begin their characteristic, volatile sublimation processes. This remarkably early activation, combined with its highly unusual velocity profile and trajectory characteristics, creates an accelerating scientific mystery that fundamentally challenges conventional theoretical models of cometary physics and interstellar object behavior. The extraordinary combination of extreme hyperbolic velocity, unprecedented trajectory parameters, and completely anomalous acceleration signatures has forced astronomers worldwide to seriously reconsider fundamental assumptions about how interstellar objects behave when passing through alien star systems, opening entirely new avenues of research into the complex dynamics governing these mysterious cosmic wanderers. Patterns in the void. The intrigue deepened when the Vera C. Rubin Observatory Analysis Group, led by Dr. Zdenka Vokrulicki, noted a trend in the frequency of interstellar objects visiting our solar system. Since the surprise of Oumuamua in October 2017 and 2I/Borisov in December 2019, detection rates have steadily increased, thanks to improved survey technology and, better international coordination. The International Astronomical Union actually convened a special panel to discuss the implications for galactic object exchange, stressing that the regular arrival of such bodies really challenges previous models of solar system isolation. Each confirmed object, now that's 3 in under a decade, forces a rewriting of our assumptions about material drifting between stars and the dynamic nature of our galactic neighborhood. Statistical analysis suggests that thousands of similar objects pass through the outer solar system undetected each year, representing a vast population of interstellar wanderers. The pattern indicates that our solar system sits within a stream of cosmic debris ejected from stellar systems throughout the Milky Way galaxy. And advanced detection capabilities promise to reveal many more such visitors, fundamentally changing our understanding of how matter moves between star systems and the frequency of interstellar exchanges. The machine hypothesis. New Webb imagery processed by the Space Telescope Science Institute in Baltimore and interpreted by a multidisciplinary panel led in part by Dr. Avi Loeb, set off debate on possible artificial origins. Loeb highlighted unexpected geometry in the object right-angle reflectivity patterns and non-random surface features that seemed inconsistent with natural formation processes. The European Space Agency's JWST spectroscopy division found thermally anomalous regions and odd shadowing that defied conventional models of cometary behavior. Team member Dr. Heidi Hamel, planetary scientist and JWST co-investigator, cautioned that such findings don't yet confirm technology, but the conversation around the machine hypothesis went global after unexpected press releases. The object's surface appeared remarkably smooth and uniform, lacking the irregular features typical of natural space debris that's been battered by cosmic rays and micrometeorites during interstellar travel. Advanced imaging revealed geometric patterns that some researchers interpreted as possible structural elements, though others argued these could result from unusual crystallization processes during the object's formation. The debate really highlighted the challenges of distinguishing between natural and artificial characteristics when examining objects from unknown stellar environments with, well, potentially different formation conditions. Spectral secrets. Spectroscopic data from the James Webb NIRSpec instrument showed 3I/Atlas contains unfamiliar mixtures of organics, silicates, and metallic alloys, not typical for solar system comets. Dr. Alan Fitzsimmons from Queen's University Belfast identified a significant absorption at 1.5 microns, associated with hydrated minerals, alongside anomalous emission lines unexplained by water or carbon dioxide alone. NASA's Goddard Space Flight Center provided confirmation, reporting faint but consistent microwave emissions that suggested active internal processes. Dr. Jessica Agarwal from the German Aerospace Center noted these combined features could suggest prior irradiation or artificial alteration of native ices, fueling both natural and technological hypotheses about the object's origin. The spectral signatures revealed isotopic ratios that differed from typical solar system materials, indicating formation in an environment with different stellar nucleosynthesis products. Rare Earth elements appeared in concentrations that challenged existing models of planetary formation and cometary composition. And the presence of complex organic molecules typically associated with biological processes sparked additional speculation, though researchers emphasized that such compounds can form through natural chemical processes in interstellar space. The information blackout. So, amid mounting discoveries, global scientists started to notice restricted access to JWST raw data beginning on August 18, 2025. Dr. Joseph Maciero of the Planetary Defense Coordination Office testified that agency data review protocols were now being applied to 3I/Atlas, and well, he cited national security as the reason for limiting information sharing. Meanwhile, SETI Institute researchers, led by Dr. Jill Tarter, raised open letters demanding transparency, and the European Space Agency's Gaia mission team quietly shared independent astrometry with their international colleagues. Tensions really flared during an American Astronomical Society session, when international collaboration took a back seat to agency security reviews. This just revealed the growing friction between open science and government oversight on cosmic anomalies. Scientists expressed a lot of frustration that crucial observation windows were being compromised by bureaucratic delays and, honestly, classification concerns. The controversy really highlighted some fundamental questions about who controls access to cosmic discoveries and whether potential extraterrestrial contact should be subject to governmental secrecy. In response, international researchers began developing independent observation networks to ensure that scientific data would remain accessible to the global community, regardless of individual government policies regarding space-based discoveries and their potential implications for national security. Controlled heat and hidden intent. Thermal mapping using Webb MIRI instruments, supervised by Dr. Michael Werner at JPL, exhibited these adaptive temperature zones across the object's surface, which honestly is not something you see in typical comets. Dr. Christina Thomas at Northern Arizona University presented findings of synchronous heat regulation, and that really stands out, especially when you compare it to the chaotic surface cooling we've seen on icy nuclei, like 67P Churyumov-Gerasimenko. Now, key data obtained near perihelion on August 19, 2025, revealed the stabilization of energy emission regions that actually seem to respond intelligently to solar heating. Theorist Dr. Gregory Laughlin at Yale even hypothesized that such signatures might imply, quote, thermal shielding or technology for intent-driven adaptation, a radical but now openly discussed possibility among planetary scientists. The temperature control followed these predictable patterns that maintained optimal conditions for preserving internal structures, and that honestly suggests either remarkable natural adaptation or deliberate engineering. Computer models showed that natural processes alone just couldn't account for the precision of thermal regulation observed across different surface regions. What's even more surprising is that the controlled heating patterns persisted, even as the object moved through varying solar radiation intensities, indicating active, rather than passive, thermal management systems that really defy our conventional understanding of cometary physics. The prime number message. Analysis teams at the Max Planck Institute for Radio Astronomy, led by Dr. Michael Kramer, detected heat emission modulations that, after Fourier transformation, revealed repeated prime number sequences embedded in the thermal output. Dr. Sophia Sheikh, a SETI researcher, independently validated a 17-23-31 pattern in night-to-night thermal variations using Green Bank Observatory data and, well, some pretty sophisticated signal processing techniques. This prime encoding is considered by scientists, as originally argued by Carl Sagan, to be the most likely signal structure used by non-human intelligences trying to communicate across interstellar distances. The findings, if verified by international SETI groups, could actually represent the first candidate evidence for information intentionally encoded in a celestial object passing through our solar system. The mathematical sequences appeared with statistical significance far exceeding random thermal fluctuations, suggesting deliberate modulation of heat emission patterns. Multiple independent verification attempts confirmed those prime number sequences across different observation periods and wavelengths. The discovery prompted emergency sessions at SETI institutes worldwide, as researchers grappled with the possibility that, just maybe, humanity had detected its first confirmed extraterrestrial communication attempt, though, of course, skeptics continued to search for natural explanations. The Watchers and the Watched. With the International Astronomical Union's special session, the world watched as experts like Dr. Lisa Kaltenegger from Cornell, astrobiologist Dr. Sarah Seeger, Planetary Protection Officer Dr. Catherine Conley, and SETI pioneer Frank Drake reflected on the profound implications of these discoveries. The paradigm has fundamentally shifted. The idea that humanity is the primary watcher of the cosmos has, well, inverted, with 3i Atlas representing potential evidence that we ourselves are being observed and studied. This reversal sparks some really intense debate about whether ethical and existential responsibilities should ever be confirmed, especially with direct, possibly intentional signatures detected in a passing interstellar visitor. The story of 3i Atlas will shape cosmic policy, philosophy, and planetary science for decades to come as humanity grapples with its changing role in the universe. Scientists are now developing new protocols for handling potential extraterrestrial contact scenarios, recognizing that traditional assumptions about human cosmic isolation may no longer apply. The discovery has prompted philosophical discussions about humanity's readiness for contact with advanced civilizations and the implications of being observed by intelligence that may have been studying Earth for extended periods. International cooperation frameworks are being established to ensure unified responses to future encounters with potentially artificial interstellar objects. The first real image from the James Webb Space Telescope begins a bold chapter in cosmic history. As data pours in and global teams compete and cooperate across boundaries, 3I Atlas stands as both a scientific puzzle and a reminder of our shared curiosity about the universe. The search for answers continues to accelerate with each new discovery. Keep exploring the cosmos with Simply Science. Like, share, and subscribe for our next cosmic revelation.